So, I think let's start the class. So today I am going to discuss some basic fundamentals of network analysis. This class will be helpful for students who are preparing for GATE exam. Also, those who want some solid conceptual understanding in basic electrical circuits. Okay, so one by one we can discuss some basic concepts in electrical circuit engineering. Okay, the first one we are discussing is these terms like the charge, then what is current, then what is voltage, then energy and power. Okay, these are some basic electrical quantities. So I am defining charge as q of t. So it's an instantaneous value based on time. I am representing charge as a function of time, that is q of t. Okay, similarly for energy I am representing w of t. Okay, energy is nothing but accumulated capacity to do work. Okay, then charge I am representing as q of t. So from this I can define current as dq by dt. Okay, here q is function of time, so dq of t by dt, this is current. Okay, I of t. I of t is nothing but dq by dt, that is rate of change of charge flow is nothing but current. Okay, now the voltage is the energy per unit charge, which can be defined as v of t can be defined as dw of t divided by dq. Okay, it's the rate of change of work done per unit charge, so its definition is dw of t by dq of t. Okay, all are functions of time. Okay, so v of t is dw of t by dq of t. So here w of t is nothing but energy here. Okay, so it's the work done per unit charge, that's called voltage. Okay, now coming into the power, power is nothing but the rate of change of energy, that is p of t is nothing but d w of t divided by dt. Okay, these are the basic electrical quantities. Okay, here we know the charge, unit of charge is nothing but coulomb, unit of current is ampere, unit of voltage is nothing but volt, then unit of power is nothing but watt. Okay, these are the units of these basic electrical quantities. Okay, now I am just deriving one equation for power. Okay, here the p of t is defined as what, dw of t divided by dt, that is rate of change of work done per unit time, that is power. Okay, this can be represented as dw of t divided by dq of t into dq of t divided by dt. Okay, this is same, right? If we cut these two terms, which is equal to this thing. Okay, so this thing can be written as dwt by dq into dq by dt. Okay, now from the earlier definition, when we look into the earlier definition, what is dq by dt? Dq by dt is I of t. Okay, similarly dw by dq is nothing but v of t. So by substituting this, I can write p of t as this is nothing but v of t into I of t. Okay, so power at an instant, p of t is nothing but power at an instant is v of t into I of t. So this is valid for any circuit. Okay, the instantaneous power is nothing but instantaneous voltage into instantaneous current. Okay. So as far as now we have discussed the basic quantities, basic electrical quantities, how these are connected. Okay. Okay. And the unit of power is nothing but watts. Okay. Watts, which is represented by letter W. Okay. So these are the basic concepts, I mean basic quantities that related to electrical circuits. Okay. Now, now we are going to discuss an important concept, that is power dynamics in circuit. As far as now we have discussed what is the instantaneous power. P of t is nothing but V of t into I of t. Okay. That is power is nothing but a rate of energy change in circuit. Okay. That is what we call power. Now this P of t is nothing but instantaneous power. Okay. This, as far as this we have discussed. Now we need to understand what is power absorption or delivery. Okay. What is the significance of its direction? Also the sign convention of power absorption and power delivery. Okay. That is very important thing here. So first let's consider a load. Okay. A element. Okay. This can be any element. Let's say this is element X. Okay. Similarly, I am drawing another element X here. Okay. Okay. Now, here, let's say voltage is marked like this. Now, the current direction is like this here. Okay. So, here, in this case, the voltage direction is same, but current direction is opposite. Okay. This is opposite. Now, let's consider the power here. Okay. Here, let's say this is a very important concept. Power power delivered and power absorbed. That is what we are going to discuss here. Okay. This is very important. Here, just look at the polarity only. Okay. Here, the current direction polarity is like this. Here it is plus, here it is minus. Okay. Just concentrate on the polarity only. Here the polarity here is plus, here is minus, and look at the current direction. Okay. So from this, don't consider this thing now, only look at the polarity. Okay. Now in this case, current direction, this direction is entering to the positive side. Okay. This is current direction is entering to the positive side. So this is absorbed power. Okay. This is represented as absorbed power. P absorbed. Okay. Now in the second case, just look at the polarity. Don't think about what is the magnitude of voltage and current. Here it is negative, here it is positive, and what is the direction of current? Direction of current is away from the positive side. Or we can say this current must enter this side, right? So here current is entering the negative side. Current is entering the negative side, or current is leaving the positive side. So in this case, we will be defining power delivered. Okay. So the power absorbed or power delivered is defined based on purely the polarities. This polarity, this polarity, this polarity. It does not depends upon the value of I or V. Okay. That's the crucial concept here. Okay. It does not depends upon the value of the I, V. It only depends on the direction of I and this positive and negative polarity. This direction of I and positive and negative polarity. So here P absorbed is nothing but when current is entering to the positive side of the voltage, then positive polarity, then we have defined it as absorbed power. That is here represented as P absorbed. Here current is leaving the positive. So it's defined P delivered. Okay. So this is how power is delivered and absorbed is defined. So this is a crucial point. Next point is very, very crucial. Okay. So please listen to me. Here, absorbed power can be positive or negative. Okay. Similarly, delivered power can be positive or negative. Okay. So this is a very important point. Here, let's consider an example. Okay, let's consider an example. Okay. P absorbed, here P delivered. Okay. Anyone listening to this? I am just curious to know. Let me check. Okay. Okay. Currently, no one is watching, but let me continue so that I can express these concepts. Okay. So here, let me take examples here. Okay. Let this be any element X. Okay. Here, this is current I. This is voltage V. Here, current is leaving. This is positive, negative V. Okay. So this is an example for power delivered. Why? Current is entering to the positive. Then here current is leaving the positive. So it's defined as power delivered. So here, let's say as a first example, say I equal to 2 ampere, V equal to 3 volt. Then I can say power delivered, power absorbed equal to 3 into 2, that is 6 watts. So here power absorbed is nothing but positive. Okay. Now let me consider another example. Okay. Another example is, let's say I is negative 2 ampere and V is 3 volt. Okay. So in this case, power absorbed will be equal to, here V remains the same, 3 into, here I is nothing but here minus 2 ampere. Okay. So when I multiply minus 2 here, I get minus 6 watt. Okay. So here the absorbed power is nothing but negative. Okay. So this is the crucial concept here. That is, here the absorbed power can be either positive or absorbed power can be negative. So why we say here absorbed power here? In both cases, we express it as absorbed power. Why? Because of the polarity. Because of the polarity, we will be defining the power as absorbed or delivered. So here the polarity is like this. Current is entering the positive side. So it's called absorbed power. So absorbed power can be either positive or negative. This can be according to the sign convention. We may take I in this direction as 2 ampere. So we will get positive absorbed power. If we keep the direction same and take I as minus 2 ampere, so the defined term is P power absorbed, but the value will be negative 6 watt. Okay. Let me consider the power delivered example. Okay. Okay. Let's see. Here I is 3 ampere. Okay. Similarly, V equal to, let's say, 4 volt. Then the power delivered here is what? Power delivered will be equal to 4 into 3, which is equal to 12 watt. This is positive. Okay. So this is the positive power delivered is here 12 watt. So let me consider another example here. Another example is, let me take this as, let's say, 5 ampere. Then the voltage as minus 3 volt. Okay. In this example, the power delivered will be equal to minus 3 into 5, that is minus 15 watt. So here the power delivered is negative. Why it is defined as power delivered? Because of the polarity. The current is leaving the positive. Okay, leaving the positive polarity. That's why we defined this as power delivered. So the value of power delivered can be either positive or negative based on the values. Here it is both are positive, so we get power delivered as positive. Here current is positive but voltage is negative. So we get power delivered as minus 15 volt. So power delivered it can be either positive or negative. Power absorbed also can be either positive or negative. But the important thing is the power absorbed and power delivered is defined based on the sign or the polarity of voltage and the current entering or leaving that circuit element. That's how the power absorbed or power delivered is defined. Okay. I think it's clear, crystal clear. So I am moving into the other part of this power. Okay. Other term. Okay. Please stay with me. This is a very important concept. It will be very helpful for the whole network analysis subject. Okay. So the next time is actual power absorbed and actual power delivered. Okay. Let me see someone is watching. Okay. Just curious to know. Okay. 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 So, what is actual power absorbed? Okay. Actual power absorbed and actual power delivered. Okay. The important thing, very, very important thing to remember is that actual power absorbed will be always, always positive. Okay. Similarly, actual power delivered will be always positive. Okay. Always positive. So, this is very important concept. Earlier, I have said the power absorbed. Power absorbed can be either positive or negative. Similarly, power delivered can be either positive or negative. But actual power absorbed and actual power delivered is always positive. Always positive. So remember this. Okay. So let me consider this example as this example as this is example 1, this is example 2, this is example 3, this is example 4. Okay, let me consider each case. Okay, each case. So in example 1, in example 1, P absorbed, the power absorbed value is equal to 6 watt. Okay, then in example 2, P absorbed equal to minus 6 watt. Okay, minus 6 watt. Okay, so in this case, in this case, in this example 1, the power absorbed is 6 watt. So the actual power absorbed is also equal to 6 watt because it's positive. Then P absorbed will be equal to actual power absorbed, that is 6 watt. Now consider this example 2 here. In this example 2, the power absorbed is minus 6 watt. Okay, so this can be written as, okay, please listen to this. This can be written as actual power delivered equal to 6 watt. So power absorbed, that is power absorbed is minus 6 watt. Then actual power absorbed is the power absorbed is minus 6 watt. So this can be written as power actual power delivered equal to 6 watt. That is, when the sign is changed from negative to positive, the power absorbed is changed into actual power delivered. Okay, so this power absorbed minus 6 watt can be written as actual power delivered as 6 watt. Okay, then in similar way, let me consider this example 3. Here power delivered is 12 volt. So the actual power delivered is also 12 volt. Okay. So in example 4, The power delivered is minus 15 watt. So what is the actual power absorbed here? Okay. Here power delivered is minus 15. So it is converted into power absorbed. So that this minus 15 can be written as positive. So actual power absorbed in this case is 15 watt. Okay, power delivered is converted into power absorbed. Why it is positive? It is defined as actual. Actual value is always positive in the concept of power. So I think I have discussed in detail what is the concept of power in or power dynamics in circuit. So once again, the power is the instantaneous power is V of t into I of t. The power absorbed or power delivered is defined purely based on the polarity of current and the voltage. So power absorbed can be either positive or negative. So when power absorbed is positive, then which is equal to actual power absorbed. If it is negative, this absorbed is converted into delivered. So negative is converted into actual power delivered. Here power absorbed is converted into actual power delivered in case of negative value. Okay. In case negative value, it is converted into positive by actual power delivered. Okay. Actual power absorbed. Okay. I think you got the idea here. The power delivered can be either positive or negative, but actual power delivered or actual power absorbed can always be positive. So convert that negative into positive by changing delivered into absorbed and absorbed into delivered. Okay. So I think the concept of power is clear to you. Okay. Then okay, identify the power is positive or negative. Okay, this is how we need to follow some steps to identify power in circuits. Okay, here calculate the power, determine the power using voltage and current. Okay, using voltage, the plus minus polarity, we can determine the power. Okay, interpret the power sign. Power sign can be either negative or positive. Okay, or it can be absorbed power or delivered power. Okay, now determine the actual power. The negative power is converted. Negative power is converted into positive power. Okay. That is in case of both absorbed and delivered. Negative is converted into positive, and similar way delivered is converted into absorbed or absorbed is converted into delivered. Okay. Depending upon the sign and whether it is defined as absorbed power or delivered power. Okay. I think the power dynamics in circuits is clear for you. Now I am jumping into Ohm's law. Okay. What is Ohm's law? The current I is directly proportional to V, or we can say V directly proportional to I. So let me consider the first one here. Okay. The current is proportional to I, and I can written as I equal to 1 by R into V. Okay. This is what we call Ohm's law. Okay. Here, important thing to remember, all these values are instantaneous values. That is I of t equal to 1 by R into V of t. Okay. This is what we call Ohm's law. Ohm's law. Let me consider the VI cara of this Ohm's law. Okay. VI cara. So this equation is nothing but it's like a straight line y equal to mx. Here in case of m, I can write 1 by r. Okay. So in case of x-axis, I will be writing v. In case of y-axis, I will be writing I. So the V I Kara will be I here, V here. Okay. Then this is a straight line going through the origin. So I can write this as the straight line I of t equal to 1 by r V of t. Okay. The slope of this straight line is y of t. Okay. This is slope is 1 by r. Okay. This is the VI Kara of Ohm's law. Okay. Now, based on this Ohm's law, I will be discussing the two conditions. This is very important. Short circuit condition and open circuit condition. Okay. Based on the Kara, I will be discussing both short circuit and open circuit here. Okay. So, what is short circuit? Okay. Let's consider a point A here and point B here. Okay. The point A and B is short circuited. Let's say short circuited. Then I can short circuit like this. Okay. Short circuit like this. The voltage across this is VAB. The current I across AB. Okay. This is I. The voltage across it is VAB. Okay. Similarly, the resistance across AB is RAB. Okay. Now, in case of open circuit, the circuit is like this: A, B. The voltage across it will be VAB, resistance RAB, then current. Let's say the current will be I. Now, let's consider the VI Kara. Okay, VI Kara here. I, I, V. Okay. Here, here, the slope here is, this section is nothing but a section of I of t, and this is V of t. So the slope here from this 1 by r slope is nothing but I of t by V of t. Okay, this is the slope. Okay, this is the slope. Let me rewrite that slope here. Okay, m equal to I of t by V of t. Okay. So in case of short circuit, okay, in case of short circuit, what happens? Okay, in case of short circuit, the resistance across A and B will be 0. Okay, in case of short circuit, resistance value is 0. Okay, resistance value 0 means what? We have equation for m as 1 by r. So when we substitute this r equal to 0 here, I get m as infinity. Okay, which is equal to infinity in case of short circuit. So the slope infinity curve is nothing but like this only. Okay, this will be that curve. Okay, I am drawing like this, but this is just a straight line. Why I have drawn like this? Because the slope is infinity. So slope is infinity. What is slope? Tan theta. Okay. Tan 90. Okay. Tan 90 degrees infinity. So I have drawn like this VI Kara. So from this VI Kara, let's understand short circuit. Here, what is the value of V here? Okay. V is in this direction. So V is defined at this point. So in short circuit, VAB will be 0. If A and B points are short circuited, then VAB will be 0. So in short circuit, the voltage across 2 points is equal to 0 from this graph. Now, the important factor is what is the value of I of t here, okay? I of t in short circuit. In this graph, I can see I of t value can be either positive or 0 or negative, okay? This is very important. This is the common misconception lot of people have. Short circuit doesn't mean high current, okay? In short circuit we can have I of t 0, positive or negative. So a short circuit doesn't always mean high current, okay? So a short circuit can have zero current also. So this is very important. This is what we get from the VI Cara using Ohm's law of short circuit. Okay. Now, now let's consider the next side. Okay. Here also M is nothing but 1 by R. But in this open circuit, this is open circuited. Let's say this is open circuited. Then what is the resistance across this? This is infinity. So what we can say 1 by infinity, which is 0. So what is the straight line which is having the slope as 0? We can draw that as like this. Okay. I'm drawing like a rectangle to get a good understanding. It's just a straight line, but I am drawing like this. Okay. So this is the VI Cara of open circuit. Now, what is the value of VAB? Let's consider first value of I here. Okay. I of t equal to, what is the value of I of t here? In this graph, the I of t value 0, irrespective of any v value. I of t value is 0 here. So I of t is 0. So in case of open circuited condition, the I will be always 0 between the points A, B. The current is 0 in case of open circuit. Also we get resistance value as infinity. Then what is the value of VAB in case of open circuit? VAB can be here negative, here 0, here positive. So VAB can be either negative, 0 or positive. So this is very important. So VAB can be any value, minus value, plus value or 0. Okay. But the current value and resistance value is always, current is always 0 and resistance is always infinity. So this is the basic core concept of short circuit and open circuit using Ohm's law. So here the most common misconception is short circuit means high current. No, short circuit means current can be positive, 0 or negative. Okay. So I'm just summarizing the key points here. Only key points here, that is short circuit and open circuit. Okay. Short circuit resistance value 0, open circuit resistance value infinity. In case of short circuit, current can be positive, 0, negative. In case of open circuit, current is 0. Okay. Then voltage is 0 in case of short circuit. Voltage is either negative, 0 or positive. Okay. This is the 4 points one has to remember in case of short circuit and open circuit. Okay. So I will be going to the next topic here. So the next topic is the core topic, very important topic in case of network analysis. That is understanding Kirchoff voltage law. Okay, Kirchoff Kirchoff voltage law, KVL. Okay, KVL is nothing but the algebraic sum of or the net sum of voltage across a closed loop is 0. Okay, we can write sigma voltage loop equal to 0. Okay, it's depending upon the energy conservation law. We are not going to the derivation of it. The algebraic sum of voltage around a loop in a circuit is 0. So that's the basic definition of a Kirchhoff voltage law. Okay, this is the fundamental concept. Algebraic sum of voltage across a loop is 0. So, in order to understand the Kirchhoff voltage law, let me consider another circuit here. Okay, let me consider another one. Okay, this is X, this is Y, this is Z. Let's say this is A. Okay. Now, let me give some polarity here. Let's say this is positive, negative, negative, positive, positive, negative, negative, positive. Okay. Let me give some polarity here. Then this is Vx, Vy, Vz, and Va. Okay. Now consider in this loop, let me consider the direction of current I in this direction. Okay. So here the first step is fixing the reference. That is the first step. Okay. Fixing reference sign convention. Okay. Okay. Here the current direction is like this. Okay. Current direction is like this in this loop. Okay. So current entering positive. Okay. Current entering positive. Current leaving positive. Okay. This is the two condition where we have to fix the sign convention of voltage. Okay. Current entering positive. Here current is entering positive. Okay. Here current is leaving the positive. So we have to take a convention or a traditional or conventional way to represent either it as positive voltage or negative voltage. So I will be taking current entering positive as positive voltage. Okay. positive voltage. Now, current leaving positive, I will be taking as negative voltage. This can be done in either ways, but it's a convention. You can take anyway. So I will be taking current entering positive as positive voltage and current leaving positive as negative voltage. So if we take this convention, then next step in KVL is, let's say, identify any starting point. Let's say this is a starting point. Then going through this loop, going through this loop in this direction all the way back to this point. Okay. So from starting point, I am entering here. Okay. Entering in the positive. What is the voltage? Vx. So I can write KVL as sigma voltage loop equal to, the first one is current is entering this positive. So I will be taking current entering positive as positive voltage. So I can write Vx, Vx, that is positive. Now again, this current is entering in negative, or we can say in this current is leaving the positive. So here Vy can be written as minus Vy. Why? Current here is leaving the positive, so I can take this as negative. Okay. Now next current is entering positive, so I can write positive Vz. Then next is, here current is entering negative or leaving positive, so I can write negative Va equal to 0. So this can be written as, again in another format, this can be written as Vx minus Vy plus Vz minus Va equal to 0. This can be written as Vx plus Vz equal to Vy plus Va. Okay. So what is this Vx plus Vz? Okay. Let me check the polarity of Vx is this, then Vz is this. According to the direction of current, here it is plus, here it is minus. That is, there is a voltage drop here, plus to minus, a voltage drop here. Here also plus to minus, that is a voltage drop here. So combining this, we can say total voltage drop equal to, what is Vy plus Va? Here in case of Vy, negative to positive, that is a voltage rise. Also Va, negative to positive, that is also a voltage rise. So which can be written as total voltage rise. Okay. This is another way of putting Kirchoff voltage law. Okay. So we can discuss these concepts in detail while doing problems. So here, this is how Kirchoff voltage law is defined. Okay. Now let's go into the Kirchoff current law. Okay. That's another important concept. Very nice. Okay. So the Kirchoff voltage law was defined based on the algebraic sum of voltage in a loop is 0. So in case of Kirchoff current law, the algebraic sum of current at a node equal to 0. Okay. This is the basic definition of Kirchoff current law. Okay. Algebraic sum of current at a node is 0. So here consider a node here. Here it is a node. current is entering as I1, this is entering as I2, this is entering as I3, this is leaving the node as I4, then this I5, this is also leaving the node I5. Okay, so current convention can be the sign convention. Here also the first step is sign convention. So in case of Kirchoff current law, current entering node, current entering node. Okay, similarly current leaving the node. Okay, this can be any convention can be taken, but I am taking current entering node as positive and current leaving node as negative. Okay, so by considering current entering node as positive and current leaving the node as negative, consider this example. I can write sigma I node equal to, here I1 is entering, so positive I1, plus I2 is entering, plus I3 is entering, then I4 is leaving, I5 I5 is leaving, which is okay, which is equal to 0. That is the algebraic sum of I1 plus I2 plus I3 minus I4 minus I5 equal to 0, which can be again written as I1 plus I2 plus I3 equal to I4 plus I5. Okay, this can be written right. So this Kirchhoff current law can be written in another way. That is, what is this current I1 plus I2 plus I3, which is nothing but current entering node, which is equal to, what is the sum of I4 plus I5? Current leaving the node. Okay, so this is another way to represent Kirchhoff current law. Okay, so in order to understand the concepts in detail, we need to solve problems. So comment, uh, if you have watched up to this, please comment your views, and if I need to continue this class, or you need more problems, or need concepts to be clarified. So whatever, you just comment on it, and I am just interested to explore more. So according to your feedback, I will be uploading content. So uh, thank you for listening to this video, and thank you. Okay, so give some comments or suggestions, or and I'm planning to do some gate problem, previous year problem uh, solutions, or something like that. I am planning to develop some study materials on gate oriented classes and problems, and creating some new problems and all. So please comment your views. Okay, so thank you for listening. Okay, and if you like this class, please share, please 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 share. Also, if you like this class, also like and support. Okay, okay, okay. Thank you. Okay, I'm ending this stream. Okay.